Okay, in this section we're going to look at solving systems of linear equations. We're going to look at the process of Gaussian elimination, and it has three things that you can do. The first thing that you can do is switch two equations. The second thing is that you can multiply one equation by a non-zero number. The third thing that you can do is add a multiple of one equation to a second equation. Okay, now this set of three things that you can do, that's called Gaussian elimination. This will make a lot more sense if we look at some examples. Okay, let's do one example here. Let's say you had a system of equations like this. So here you have two equations and two variables, x and y. So this is a system of two equations in two variables. What we want to do here is try to get rid of this x variable here. So let's do -4 times the first equation add that to the second equation. If you multiply the first equation by -4, this part will become -4x. That will add with this 4x in the second equation and give you 0x. That will cancel out the x variable. So let me multiply the first equation by -4. And then I leave the second equation as it is. Now here we see -4x and we see 4x here. Let's add these two equations. I get 0x plus 9y equals to -4. 0x is just 0, so I get 9y equals to -4. Let's solve for y. Divide both sides by 9. And you get -4/9. I want to find what x is, so I'll plug this y value back in to the first equation. X minus 2 times -4/9 equals to 1. Now simplify this. Solve for x by subtracting 8/9 from both sides, and I get 1/9. Okay, so x equals to 1/9. And y equals -4/9. 4/9. So these are your values for x and y, and that's a solution to this system of equations. Let's do another example. Let's say we had this system of equations. Let's multiply the first equation by -2 and add to the second equation. Okay, so we're going to add these two equations. I get 0x plus 0y equals to 1. And this left-hand side equals to 0. So we get a contradiction here. Since we get a contradiction here, the original set of equations has no solution. Okay, let's do one more example. Alright, let's try to get this to be -14 so that the x variables cancel out. Let's do -2 times the first equation and add it to the second equation. And the second equation just stays the same here. Okay, now let's add. I get 0x plus 0y equals to 0. And so 0 equals to 0. Well, that doesn't really tell me anything. If you look back here, notice the second equation is just twice the first equation. So really, we only have just one equation, just the first one. The second equation is redundant. So this is all we have here is this equation. Note y. Y could be anything, so let y be some parameter t, some variable t. Let's plug that in for y here and then solve for x. 7x plus 5t equals to 2. Let's bring that 5t over to the other side. divide both sides by 7. And this is what I get. So the set of all solutions is going to be the set of all pairs x and y. Let's write x in terms of t as we have solved for it here. And y is just t. And t is a free variable, so it could be anything. It could be any real number. So we write it like this: t lies in the set of real numbers. Okay, so the set of all pairs like this, where t is any real number, those are the solutions to this original set of equations.